Chapter 5 is about understanding and comparing distributions. What we're going to focus on now is just comparing distributions. So the example that we're going to be using throughout this lesson is about the average wind speed over the course of a year. So we're starting with a histogram and a box plot of the exact same data. So really we just want to be able to see what we can tell about a distribution from a histogram and what we can tell about a distribution from a box plot and how they might be different. So if we're looking at the histogram, we can see that it is unimodal, skewed to the right. There's an outlier around 9 miles per hour, and that's about it. We can estimate a rough center, but that's overall what we can really tell. If we're looking at the box and whisker plot, we can't tell that it's unimodal, but we can still see that it's going to be skewed to the right because the second half of the data is much longer than the first half of the data, indicating that it's going to be skewed to the right. Also in the box and whisker plot, we can see that there is this extreme outlier here, but that these are also outliers as well, and we can't see that in the histogram. The other thing that we can tell in the box and whisker plot is we can see what the median is right off the bat. We can also determine what our IQR is, which gives us a better understanding of the spread. So in both displays, we can see different things, and in some cases we can see the same thing, and both have their place. More often than not, we'll probably be using histograms, but it is important to be able to use a box plot as well. Comparing groups is often more interesting than just looking at one set of data. When you're using histograms or box and whisker plots, you always need to note the shape, the center, and the spread of the two distributions. Now, when you're doing this, it's not enough to list the distribution of group A is this, the distribution of group B is this. You're not comparing anything. So to compare the distributions, you actually have to make comparative statements. That is extremely important. So here we're still using our average wind speed, but now we've broken up into two different groups of seasons. So the spring-summer seasons and the fall-winter seasons. So before you actually start comparing the distributions, make a note of the distributions of each group separately. So in spring-summer, we can see that it's unimodal, skewed to the right. The center is around, say somewhere around in here, which is about 1.5, and it ranges from 0 to about 3.5. In the fall-winter, again, we have the same shape. We're unimodal and skewed to the right still, but this time our center is more around 2.5, and our spread goes from 0.5 to all the way up to about 9. And the other thing to note is that in fall-winter there's an outlier, whereas in the spring-summer there is not. Now, once you have made a note of the distribution of each group separately, you want to actually compare them. So written out, this would look like the distribution of average wind speed for both spring-summer and fall-winter is unimodal and skewed to the right. However, there is a possible outlier around 9 miles per hour in the fall-winter. It appears to be a bit windier in the fall-winter with a center around 2.5 miles per hour, where the center is around 1.5 miles per hour in the spring-summer. The spring-summer seems to have a more consistent average wind speed with a smaller range compared to the range of the fall-winter. Overall, it appears to be windier in the fall/winter. So note here that I did not just list each group separately. I compared the two groups together. I compared their shapes, their centers, and their spreads. I also made sure that I included the context so the reader knows that we're talking about the average wind speed and what units we're using. Again, you have to make comparative statements. When comparing groups, it's often easier to use box plots than histograms because box plots we keep side by side on the same scale, so we can easily compare their centers and their spreads and look for commonalities and differences in their shapes and in outliers. Whereas in histograms, the histograms have to be kept separate. Now we can still compare groups using histograms, but we want to make sure that they have the same scale and that the bin width is going to be consistent. So that way we are looking at the data displayed in the same way. But again, box plots are often easier to compare groups. For example, we can break our average wind speed into the different months, and here we can very easily see how the data behave over time. So going from January to December, so we're in the winter months, and we already decided that it was a little bit windier in the winter and fall months. So as we get into the spring and summer, we can see that the median wind speed starts to decrease, and then once again it starts to increase. We can also see that in the fall months and winter months, we tend to have more outliers, or larger outliers, I should say, than in the spring and summer months. So again, keeping them side by side, it is easier to compare them. When we are talking about outliers, again, I know I've already said this, but it is important that when you are giving the mean and standard deviation and there are outliers present, you need to give the mean and standard deviation both with and without the outlier. With the median and IQR, they are not affected by extreme values, so you don't have to report them twice, you only have to do it the one time. Alright, so that is it for today's video. I'll see you guys in class tomorrow. Have a great night.